Hello everyone, in today's video we are going to learn how to prepare a square butt joint on SS sheet 2 mm thick in flat position 1G.
Objectives. At the end of this video, you will be able to clean the chromium oxides and other impurities that exist on the surface of the stainless steel sheet. Prepare square edges on stainless steel sheets. Apply stainless steel flux to the edges of the sheet to be welded. Select a suitable stainless steel filler rod, nozzle and gas pressure. Set a perfect neutral flame. Weld the square butt joint with uniform root penetration using the leftward technique. Clean the joint and inspect for weld defects. Let us collect the tools, equipment required to make this practical. Gas welding plant, SS flux, bench vise, steel ruler, wire brush, chipping hammer, flat file, tongs, scriber. Materials required to make this practical. 2 SS pieces with diameter 150 multiplied by 50 multiplied by 2 mm. Step 1. Prepare the stainless steel sheet as per dimensions given in the sketch. Take a 2 mm thick stainless steel plate. Mark the dimensions on the 2 mm stainless steel, length of 150 mm and breadth of 50 mm using a scriber. Cut the SS plate as per the marked dimensions using a cutter. Step 2. Clean the edges of the sheets. Use a stainless steel wire brush to clean the edges of the sheets and remove any chromium oxide and other impurities from the edges. Removing chromium oxide from stainless steel edges requires careful consideration, as stainless steel's corrosion resistance relies on the formation of a passive chromium oxide layer on its surface. Removing this layer can compromise the steel's ability to resist corrosion. Step 3. Select the nozzle number 5 for 3.15 mm thickness. Select nozzle number 5 and fix on the blowpipe. Select a 1.6 mm Phi specially treated columbium bearing 18 by 8 type stainless steel filler rod, or cut strips from the base metal to use as filler rod. 18 by 8 stainless steel means the alloy steel contains 18% chromium, 8% nickel, and the balance percentage is iron, carbon percentage, etc. Step 4. Select the stainless steel flux and apply on both sides of the edges of the joint by using a 12 mm paintbrush and apply on filler rod. Select good quality flux which contains zinc chloride and potassium dichromate. Make powdered flux in a pasty form by adding water. Apply the flux on both sides of the plate and filler rod. Step 5. Set the sheets as butt joint on a thick metal plate with 1.5 mm gap. Set and align the stainless steel sheet as square butt joint. Step 6. Set perfect neutral flame. Set a strict neutral flame or slightly carburizing flame so as to prevent the formation of oxidizing flame, which is harmful. In gas welding, using a neutral flame is crucial for achieving proper weld quality and preventing oxidation of the metals being joined. The neutral flame is a specific type of flame produced by a controlled mixture of the fuel gas, acetylene, and oxygen. It provides the right balance of heat and protection to ensure a clean, strong weld. Step 7. Tack weld at every 50 mm length of the butt joint. Tack weld on both ends of the joints and for every 50 mm in between them. Tack welding is a technique used in welding to temporarily hold 2 or more pieces of metal together in the desired position before a permanent weld is made. Tack welds are smaller, less intense welds that provide enough strength to hold the pieces together during the welding process. Step 8. Weld the joint using leftward technique. Start welding from the right-hand side by holding the blowpipe at an angle of 80 degrees to 90 degrees and the filler rod at 20 degrees to 30 degrees. Hold the welding torch at the correct angle and distance from the joint. Start the welding by striking it on SS and begin moving the torch from right to left along the joint. Keep a consistent travel speed and maintain a slight backward angle to ensure proper penetration. Ensure uniform penetration at the root of the joint. Finish the weld by filling up the crater at the end of the bead. Clean the weld bead and inspect. Ensure the complete removal of the flux residues. Step 9. Clean the joint and inspect the weld for defects. Porosity is the presence of small cavities or voids in the weld metal caused by trapped gas bubbles. It weakens the weld and makes it susceptible to cracking. Undercut is a groove or depression formed at the base of the weld due to excessive melting of the base metal. Incomplete fusion occurs when the weld metal does not fully bond with the base metal or previous weld pass, resulting in a weak joint with potential for cracking. Lack of penetration happens when the weld metal does not fully penetrate through the entire thickness of the joint. Overlap, also known as overlap beads, is an excess of weld metal deposited beyond the joint's intended boundary. It can create an uneven and weak joint. Spatter refers to the tiny droplets of molten metal that are expelled from the weld pool during welding. Weld cracks can occur for various reasons, including high stresses, improper cooling, or hydrogen embrittlement. Inclusions are foreign materials such as slag, flux, or dirt trapped within the weld metal. Recap. In this video, so far we have discussed: clean the chromium oxides and other impurities that exist on the surface of the stainless steel sheet. Prepare square edges on stainless steel sheets. Apply stainless steel flux to the edges of the sheet to be welded. Select a suitable stainless steel filler rod, nozzle, and gas pressure. Set a perfect neutral flame. Weld the square butt joint with uniform root penetration using the leftward technique. Clean the joint and inspect for weld defects.
Thank you so much for watching this video. Please do this practical with the help of your instructor. Happy learning!